comfortable to appear for such exams? First of all, why to appear for such exams? क्यों करना है? आपको किसी ने बोला इसके या है? Have you appeared for any of the competitive exams till now? क्या क्या की? कोई बता सकता है? SOF ठीक है, ओके. और अदर और कुछ है? स्कॉलरशिप की एग्जाम थी आपको स्कूल में? टैलेंट सर्च? सॉरी? गुजरात स्टेट क्विज. और कोई? ओके, वेरी गुड.
सर जीके के बाद मार्क्स करेंगे.
ओके. और कुछ? ये NDS बोला ना आपने? फुल फॉर्म? नेशनल डिफेंस एकेडमी. ओह, NDA. ओके, फाइन. ग्रेट. आपने इंडिया भी दे दिया? अच्छा, आप 12th में हो? ओके, फाइन. Whatever exam that you give, of course NDA उन्होंने दिया, कुछ मकसद से दिया है, right? So you want to get into forces. Great, very good. I mean, if you really want to get into forces, raise your hands. Forces यानी फिजिक्स वाले नहीं. Okay. Good, very good. So you have certain ambition over there, right? When you prepare for such exams, when you prepare for any of these exams, आपको क्या मिलता है? एग्जाम के बाद सिलेक्शन होना तो वो तो अलग बात है. प्रिपेयर करके क्या मिलता है? Exposure. You get exposed to such kind of questions. You get trained to attack such kind of questions. Right? So similarly, when you appear for Olympiads, right, the kind of questions that you come across, these are conceptual questions, these are thematic questions. There are different types of questions, right? And that actually prepares you. It actually prepares you to think from different point of views, right? And that's why you should appear for such exams. So this is an individual competition. Okay. So normally it's not the competition between countries, but if it's a 5-member team, then it's basically an individual competition. So ऐसा बच्चा अच्छा करता है वो उसको मेडल मिलेगा. But after that, then people come together and then say कि okay, चाइना को कितने मेडल्स मिले हैं, USA को कितने मिले, इंडिया को कितने मिले हैं, and then they उनके बीच में ही हाँ अभी चाइना फर्स्ट है, इंडिया थर्ड है, सेकेंड है. That's what happens, right? So it's still an individual competition. So it's a 5-student team for physics, okay, with some team leaders which go to the international conference. It is governed by syllabus and statutes formulated by this international board, which is almost equivalent to our JEE. Okay, so except there are few more topics added like modern physics and relativity, which are not there in JEE. That level, Fermat's principle. So there are some topics like this, and of course, cost of it borne by the host country. So it actually started in 1967. बहुत पुराना. Started in 1967 with very few countries to start with. So you can see, like less than 10, around 5 or 6 countries initially participated. And now the graph has gone and it has actually reached a saturation. So every year there are 80 to 85 countries participating in this competition. And this blue chart that in 2015, India hosted this competition in Mumbai. And HPCSC being the nodal center for Olympiads, we had this responsibility of developing the theory and experimental problems for this competition as well as managing all the related arrangements for this competition. It was 2015. So we started participating officially in 1998 with a request from Government of India to our center that let's try and see whether we are of that international caliber or not. देखते हैं participate करके कैसा होता है India, can it participate, does it get any medal or not. And this Indian effort is coordinated by HPCSC with the help of an association called Indian Association of Physics Teachers. IAPT. Have you heard of this association? Okay. Anybody from that association had a conversation with you? कोई lecture या कोई आपने किसी से मिले हो आप? नहीं? Okay. Surprising. Because we have, I mean, IAPT is pretty active in Gujarat. There are people from Gujarat, I mean, we have been hearing a lot from them. And unfortunately, this year they are not there, but I think for last 2019 and 18 when I came here, they were there to talk with you. Hopefully, you will get to meet them. So this is an organization, an NGO, very active nationwide. Their teachers, these are all physics teachers, and they work voluntarily. They work voluntarily for you all. आजकल वॉलंटरी का मतलब ज़्यादा समझ नहीं आएगा. Without any monetary benefit, no money, they don't charge anything. और ऐसे लोग कम मिलते हैं. Medals tally. None of the students so far has written empty-handed. So in cricket language, our strike rate is 100%. Every student who has gone has come back with a medal, either gold, silver, bronze, or other dimension. And nowadays, we do get at least 2 or 3 golds. That just means that we are good. We means you people are good. Okay? So you people are really good, so that you can even compete at the international level. Okay? What you require is just to practice. So that's the medal tally. I mean, I just don't want to impress you too much about this, but we have been getting sufficiently good amount of golds, okay, and silvers and platinum. And this is the flow chart, how it goes. Of course, last 2 years were like, you know, they just didn't exist in our life, right? 2020 and 21, India did not participate. For obvious reason, because of this pandemic. But other than that, this is the structure. Due to pandemic, we had to change the format a bit, but now this year we are again coming back with the same pattern of the examination. That is, the first exam will be in November. Okay, so it will be called as NSE, National Science. So that is basically conducted by IAPT at around 900 centers all over the country. Then I know Indian National Olympiad conducted by BCSC, and then basically from second stage onwards we take. So the first exam, there are around 60 to 65,000 students appear for this, and then the number has been increasing. For the second, we select around 300 to 350 students, and that is held at around 15 to 19 centers all over the country. And from that, we select 35 students, around 35 to 40, which come to our center in Mumbai. We train them in experiments because when they come, we find that theory they are pretty good because they have been preparing for such kind of problem solving for quite long time. But then in experiments, the situation is not really good because of an obvious reason. टायर पंक्चर हो गया साइकिल का, क्या करते हैं? पंक्चर वाले के पास जाते हैं, हम थोड़ी ना करते हैं, है ना? लीक हो रहा है कहीं पे नल घर में, do we open it? Do we repair it? लैब में कुछ खराब हो गया, एमीटर खराब हो गया, what do we do? What do you call? I mean, kaka, mama, what do you call? There must be some name who gives you the apparatus and then uncle, whatever it is. क्या बोलते हो? Kaka. Same. I mean, this is universal name. Okay? So you get it from your kaka and then fine. You believe that everything is working, but if it's not working well, what do? Just replace it. We don't apply our mind कि अरे ये खराब हुआ है तो Is there any way to repair it? You don't even discuss that. Right? That's the problem. The problem is doing something, okay, trying to troubleshoot something, trying to understand how that system behaves, okay, is not there. That this tradition itself is not there. That's why the students who come, these 35 students who come to HPCSC, they are pretty good, very good in theory problem solving, but unfortunately not so good in experimental problems. Okay. And we will discuss that later. So just skip this. Very important, this is the only official program in the country. Somebody just mentioned SOF, right? That doesn't lead you to international Olympiads. Right? So this is the only Olympiad which takes you to the international Olympiad, which is funded by Government of India completely. Right? When I say funded by Government of India, it just says that at first stage you pay around 100 to 150 rupees. If you are talented enough, you don't have to pay a single rupee till the international travel. Nothing. Everything is sponsored by Government of India. So that's why this is the only official program in the country, and Hungaba Center is the nodal center for this approach. So as Pulkit sir said in the beginning, physics, chemistry, biology, mathematics, junior science, and astronomy. So these are the Olympiads that HPCSC handles. So this is the information which you will get from this website quite well. So I will not spend a lot of time on that. So these are the examinations now. This year it's going to be on 27th of November. So generally on the last Sunday of every November. So that is the first level exam. This is the website from where you can get all this information and then where to go and fill the form and all this. Right? So pretty easy to get that information. Right? iipt.org.in. Writing it. I think if you have seen the first slide, have you seen the first slide where the title of the talk was written, and have you copied down my email address? Great. So if you have copied down my email address, just write to me. You can even get this PowerPoint slideshow. There is no copyright. Whatever that I am telling you, if you want to remove my name and give this talk to somewhere else, that's also fine with me. Okay. So don't spend time in writing these things. I mean, if you can just write an email to me and you will get the whole material from me. Professor B.P. Tyagi is the chief coordinator. He is from Dehradun now. So he manages it from Dehradun, the whole network. Okay, so for the first level, the question paper consists of two parts, part A and part B. So part A is 48 multiple choice questions with one alternative correct. Part B, 12 multiple choice questions, okay, with multiple options correct. In part A, you have this marking scheme, +3 and -1. And in part B, to get it, all the correct options should be marked and no incorrect option should be. That's right. Some questions, let's start with this. Okay, close your eyes. Option A, B, C, D. Okay, fine. Open your eyes. Great. Now, just turn to your neighbor and discuss. Okay. Why do you think this can be a correct option? If your neighbor is also same answer, then I cannot do it. But then, if I say that this is the correct option, why do you think so? I need a justification for this. Okay, any justification? No? Sure? Nobody wants to say anything? No cannot be the option. What did you discuss? So let's try to understand what is your justification for your answer.
G is the electric gravitational field due to Earth, so it is independent of the rotation, just depends on mass.
Okay, so if it stops to rotate, what will happen? See, suppose if you have a simple analogy to that, okay, if you have some object rotating on quite fast, okay, what will happen? Another analogy, if you have a magnetic sphere,
So if something is rotating, then there will be some centripetal force.
centripetal.
Centrifugal.
So if you reduce that speed of rotation, that will reduce. So which will win?
Then it will attract.
Gravitational attraction. That's the simple analogy. This is very simple. Very simple. The moment someone here says very simple, tension will become. It's really simple. Okay. Option A. Forgot. You all forgot to close your eyes. Option A. Okay. Option B. C. D. Okay. It seems C is supposed to be very favorite later on. And if you have studied springs, so if you take a spring and cut it, okay, and then if you have two springs, so K1 and K2, how do they behave? If they are connected in series, if they are connected in parallel. Just think about it, and that's the only hint about this question. I guess this will take some time. Think about it. Okay? Wait. You have any doubt about the question or no? Okay. Answer. Okay. Close. So initially, where is the station? Center. So as you are adding some mass, which is going and settling at the bottom, where will it go for? Towards the bottom. Start going up. That's that. And this kind of questions are quite popular in most of the competitions. They tell you all sorts of situations, and then they ask you to get distance time graphs, velocity time graphs, acceleration time graphs. So there is a ball which is projected vertically upwards with the velocity v. It comes back to the ground in time t. So which is that velocity time graph that you are going to choose? It shows the motion correctly. We don't have to discuss now. Okay, fine. Have you made up your mind?
Yes, sir.
Great. Close your eyes. Option A, option B, option C, option D. Okay. Except option D, there were like equal number of people who were answering that. And this is so this question looks pretty simple that way. It's not really very simple. Not really very simple. C. Your favorite option. You should have said the major misconception in this is that it changes the direction. Right? So it just crosses that axis at that 0 point, changes its direction. That's that. And of course, then there are some subsequent questions on this. Let's talk. So the questions are like, can you plot distance time graph for this? Can you do that? How will the distance time graph look like? Very good. Parabola. How did you arrive at that? So who answered that? Okay. How did you arrive at that? You don't have to stand, but you have to speak louder. That's a statement that you have made, but how? So what operation that you have done with this graph? From velocity to time, when you have to go, okay, how are they related? Velocity is dx by dt. If I have to get x, right? So dx is equal to v into dt. Right? So I have to integrate that. Then if you integrate that, you should get the right? That's the idea. If you really try to understand this relation and then try to imagine how it will look like. So when you go back, try to do this for different motions. You just go on Google and then try to give a search like velocity time graph questions or say acceleration time graph questions. And that will give you a practice of looking at such graphs and understanding how that motion is actually. Right? And these are very repetitive questions in most of the cases. Done? How many of you say A is correct? Now you don't have to close your eyes. That's okay. There are more than one option. So the probability is more that you might commit a mistake. And now I think we know each other. Okay? And your teachers also know you. Okay. A option. If you are raising your hand, raise it properly. It should not be hard. Okay. Why do you say so? How did you arrive at? Obviously. That's what we have to do, right? So what is angular momentum? MVR and Planck's constant you can get from E by nu. So those who have still have not answered that, can you just write it down? Try to just do some jugglery with those variables. Angular momentum is mvr, mass, velocity, r is radius, right? So m, then what is the dimension of wheel? L by t, and r is L. Now, so I think getting dimensions for L is not a big problem, right? It's pretty quick. For H, take E equal to H nu. I mean, you arrive at that quantity by using any dimension formula that you is comfortable. So energy dimensions, you take any energy, take mv square, and nu frequency. That is the only way you have to do, right? If you know the formula, you just have to plug in that. Impulse, f dot delta t, right? Momentum, mv. You know the definition of force, right? M delta v by delta t. Okay, so if you multiply that by delta t, it will be just m delta v. And your momentum is also m. Young's modulus, stress. What is Young's modulus? Stress upon strain. Strain is dimensionless. None. So try to know this formula, and you come to know this formula from your numericals. Either numericals or you know the definitions quite well. You know the definitions quite well, then you solve problems. So this is like cycling. Second level, okay, so from the first level we select around 300, and then this is like duration of 4 hours problems, okay, and these are subjective problems. Now the objective. Objective component in this, so it's all problems. These are like thematic problems, but we'll not be getting into those problems right now because if you start with one such problem, it's going to take a lot of time and we will not get it. And there's like mixed problems. I don't want to scare you with those problems right now, but we can always just write to me and I can send you a set of problems, solve it, send it back. Hello. Am I audible? Yes. So from the second level, when you come to the CAN, these are like 35 students who come to the CAN, and in this we have both theory exam as well as experimental exam. So there are typically 3 theory exams and then 3 experimental exams. A typical exam, theory exam or experimental exam, is of 5 hours. In that 5 hours, in theory exam, you just have to solve 3 problems. Only 3 problems in 5 hours, but these are quite long problems. For example, let me give you an IPHO, like the International Olympiad Examination problem. In Indonesia, the problem was on volcanic eruption because Indonesia is famous for that. So it's kind of a thematic problem. Now that problem they converted into a thermodynamic problem. In Iceland, again, there are like small volcanoes under the ice caps. So one more problem, like if you take your normal pencil, right, with hexagonal cross section, if you put that on a inclined plane, what will the motion of that be? Will it just slide or will it roll? So it depends at what angle you are going. So these are some of the thematic problems that they normally try to come up with. For example, in India when we hosted it, there was one problem on nuclear reactor, design of a nuclear reactor. It was like mainly, with the permission from BRC. So people from BRC actually came together and they made it into a 12th standard level problem. How do you design a nuclear reactor? What do you mean by criticality? All those things were involved. And let me tell you, all these problems are available on the internet. If you are not satisfied with only these problems, there are some more problems available under the website called as Physics Cup. If you just give a search as Physics Cup, if you are really interested in solving good problems, this is a website maintained by a person from Estonia, Jan Kalda, and he conducts this kind of a competition every year. Of course, it doesn't give you prizes or anything, but this is for those who love problem solving. And then he awards some certificates and all, but that's not a major thing. But then those solutions are also discussed in that. So these are very beautifully available kind of a khazana of promises. Of course, when you come to Ulava Center, we give you some kind of orientation, okay, because not all have entered the lab and looked at the instruments the way you should have. There are certain lecture sessions, not just theory but even on experiment. Theoretical examinations, experimental examination, one student, one apparatus, 5 years. So let me now jump on to this experimental component of this EPR. And when I say experimental component, these are the three things which I am going to discuss. Something known as procedural understanding, the process of solving an experimental problem, how do you approach that, and then some experiments. So I would like to discuss some of this. So what do you mean by procedural understanding? It's thinking behind it. The moment you enter a lab, you perform any step. Always a question asked, why? Why not the other? Why this instrument? Why not the other? So the decision that you have to make for doing a laboratory, that procedure is. Let's have some examples of that. Now, again I am going to ask you this question that you have to measure voltage in a circuit. And I am giving you analog voltmeters. You know analog voltmeters, right? Pointer रहता है. So it's a 0 to 2 volt analog voltmeter. Now the reading shown by the pointer moving over a dial, the reading is constant, right? We have used that analog voltmeter and then the pointer is showing you a constant reading. When the same is measured by a digital voltmeter, again same range, 2 volt, the large reading is found to fluctuate. Analog निकाला, digital डाला, it fluctuate हो रहा है. Which meter should one prefer? Digital or analog? Think about it. How many of you say analog? Raise your hands. Digital, raise your hands. So there is a majority of girls over there. Why is that? What about this side? यहाँ पे कुछ आते नहीं ऊपर हुए. Or you are still not clear. Again, analog, raise your hands. Digital, raise your hands. भी आ गए यहाँ. Same school. Same school. and for analog, right?
Voltmeter can have some inaccuracies, and it depends on the quality of the machine.
Depends on
The quality of the digital board.
no, I give you the best quality digital. No, I mean I'm not joking. I can give you a best quality digital multimeter. Means those who know that there are different types of digital multimeter. There are also something known as QRMS type digital multimeters. They are the most expensive ones. Yeah, I give you that most expensive. Analog.
जो बैटरी उसके अंदर पहले से प्रेजेंट होगी शायद उसके अंदर
नहीं फॉल्ट नहीं है उसमें यार मल्टीमीटर में फॉल्ट नहीं है आई मीन आई एम नॉट गोइंग टू प्ले अ ट्रिक विथ यू ऐसा नहीं है कि मैंने कुछ फॉल्ट वाला दिया आपको और इसलिए वो हो रहा है बोथ द मल्टीमीटर्स आर परफेक्टली फाइन दे आर द बेस्ट क्वालिटी मल्टीमीटर्स दैट आई हैव गिवन यू अंदर का बैटरी वगैरह सब परफेक्ट है नया
Sir, I think so. Digital voltmeter will consume some of the electric current that would make us. So it would be some fluctuation in that.
that's what I'm trying to tell you so it is not a problem of the multimeter that I'm talking about why do you say that? Your answer is correct why I would prefer digital. Why? So that's a problem now. But can you reframe your answer a bit? We'll just hold for some time. Somebody just said, the range is same. Range is same. When the current flows through the voltmeter, what happens? Analog. Digital. Why? Why? I mean, will the current know कि अभी मैं digital में से जा रहा हूँ तो okay, अभी मैं उसको fluctuate करवा देता हूँ. No, okay. Those who have actually handled these both multimeters, analog as well as digital, this analog multimeter, the pointer that you see, at the origin of the pointer, you find a coil there. So what that coil tries to do, how many of you know Faraday's law and Lenz's law? Lenz's law, Faraday's law, all in the others. What is this? आप Faraday's law करके ही पढ़ते हो ना वो गुजरात में आके कुछ नया वगैरह Faraday का गुजरात वर्जन वगैरह पता है so if it's so what it does you know eddy currents right so analog voltmeters whatever fluctuations that you might have so fluctuations are suppressed they are suppressed because of this eddy current Hello. So in analog, these fluctuations are suppressed because of the eddy currents, and that's why you see pointer to be a stable. Okay, whereas in digital, you don't have any such kind of value. Okay. But why should we prefer digital over analog? Because what is the purpose of doing an experiment? Not just that, but to understand that whether the circuit, the voltage that you are measuring in that particular circuit, whether it's giving you a stable value or not, or any fluctuations. If there are any fluctuations, why are those fluctuations? Is there some certain component which is not correctly soldered, not connected properly? Or is there some line voltage which is very line voltage in the sense 230 volts? Right? Do you know that even that changes? How many of you know that there is like this line voltage also change? How many of you don't know that it changed? यहाँ पे क्या हो क्या रहा है यहाँ पे? Okay, let me ask you this question again. How many of you know or does not know that the line voltage, this AC voltage, changed? You did not know. Okay, fine. How many of you knew that it changed? Okay, fine. And remaining hands I didn't bother. मुझे क्या जाता है चेंज होना हो, मेरे लाइफ में थोड़े कुछ होता है. The idea is, see, there are certain fluctuations, and then these fluctuations, when they become prominent, okay, then you try to see that some kind of a flickering in the intensity of the pulse. If they are not prominent, which you cannot notice it by your eyes, then you don't feel that there is any fluctuation. But if you really have a multimeter and try to check that over a certain period of time, you will find that there is some kind of value changing over a certain period. Right? That is line voltage variation. So these fluctuations can be due to any factor. And if you really are doing an experiment, it's best for you to understand what are these fluctuations are occurring. So for example, tomorrow if you are really doing an experiment, developing an experiment, and if there are some problems that are coming up, if you go to some research lab or something, it's your experiment that you are going to do, and you are getting certain variation in the intensity of some laser diode, which is connected to some adapter, which is connected to some AC source, you should be aware that yes, there are certain changes like that. So the idea of doing any experiment is to understand what are the problems in the experiment. So next, this is a tube, okay. A plastic tube. You have to measure length of the tube. Simple question. How will you measure? Scale. The answers are very simple. The interpretations are very difficult. Scale. Take a scale and measure. Do you find any problem with that? What? You said yes, so what can be the problem? नहीं लेंथ मैंने लेंथ ही लिखा है ना लेंथ. So ट्यूब का लेंथ, डायमीटर से अभी तक मुझे कुछ लेना देना नहीं है. You will be no मैंने वो निकाल दो ना, सीधा करो उसको. मैं ऐसे नहीं बोल रहा हूँ, इसके अलग मेजर करनी है तो करनी है. Okay, fine. Let me put this question in a different format. आपको एक ट्यूब दी गई है, मैंने उसको सीधा किया आपके लिए, और इन्होंने मुझे स्केल दी है, मैंने इसको मेजर किया. Is the problem over?
सर हमको स्केल भी देखनी पड़ेगी. स्केल में रीडिंग्स कैसे, जैसे कि अगर रीडिंग बड़ी हुई 6 सेंटीमीटर में रीडिंग हुई तो उसके हम एग्जैक्ट मेजरमेंट नहीं बता पाएंगे कि कितने मिलीमीटर में भी है.
चलो मैंने मिलीमीटर वाली दी इसकी 0.1 सेंटीमीटर ली इसका. नो इश्यूज? श्योर? किसी को कुछ सूझ रहा है? You have some? अच्छा ऐसे ही. Normal temperature. Wait. Now the question that you asked, okay, what will happen if I change the temperature? Okay. Even at normal temperature, is there any possibility that might get stretched? Sure. I'm giving you a scale. This is a stretchable tube, plastic tube. कभी जब आप मेजर करने जाओगे, you try to be really good ना while measuring, right? तो फिर मैं एक यहाँ पे लगाऊंगा, एक यहाँ पे एकदम अच्छे से लगाऊंगा. मैंने ऐसे अच्छे से I might stretch it a bit, right? Then I realized नहीं, मैंने कुछ ज़्यादा stretch कर दिया उसको, right? Fine, you might hold it a bit loose. You might get certain variation in that. Okay. Solution क्या है? Is there a solution to this? Solution बहुत simple है. हाँ, वो मैं आज कुछ नहीं दे रहा हूँ. See the problem. See, he knows the solution to that. Okay, but the problem is you have to search for the recipe which is not expanded. समोसा खाते हो आप? समोसा कैसे लाते हो? Don't tell me कि अच्छे से बॉक्स में पैक करते हैं. वो पॉश दुकान वाला नहीं. वो रोड साइड वाला समोसा वो धागा बांध के देता है, राइट? धागा भी स्ट्रेचेबल रहता है. वो धागा भी स्ट्रेचेबल रहता है. सिंपल पेंडुलम के लिए आप थ्रेड यूज करते हो? धागा कभी देखा है आपने वो? By definition, it should be non-stretchable string. But then if you try to stretch it, वो stretch होता है. फिर टीचर क्यों देते हो? For that mass of that bob, you can consider as non-stretchable. यहाँ पे क्या हो रहा है? If I am getting variations in the reading, okay, what should be the solution to that? Take it multiple times. Statistics will help you. Averaging, exactly, averaging. So कभी भी जब ये ऐसी situations आती है कि you get variations in your reading, you take it multiple times. Simple pendulum किया है आपने? किसी ने भी नहीं किया अभी तक? कितने जन ने किया है सिंपल पेंडुलम? सिंपल पेंडुलम एक धागा है, उसको बॉब है. यहाँ भी नहीं किया है. You are from which standard? 11. Okay. तो 12th में है क्या? अच्छा बाद में है. ओके, नो प्रॉब्लम. पता तो है ना सिंपल पेंडुलम? पता है कैसे होता है? धागा है, एक बॉब है.
वाला पता चला दिल्ली और
जिन्होंने किया है, आपको टीचर्स ने बोला था कि टाइम आपको ज्यादा बार लेना है. T1, T2, T3, 3 टाइम्स. सच में लिया है या एक बार लेके 2 बार लिया है? क्यों बोलते हैं वो? You get variation. You get variation. So wherever you get variation in your answer, you have been asked to take things multiple times. Inner diameter. अभी हम diameter का. Inner diameter कैसे करें? क्योंकि अगर मैंने आपको वर्नियर कैलिपर दिया, वही वर्नियर कैलिपर वो मेजर करेंगे. The problem is with the vernier caliper will be तो ऊपर वाले जॉज जो है वो आपकी इनर डायमीटर मेजर करेंगे. But the problem will be again when you try to measure it, that you might get stretched. Is there any indirect method that I can use? How? कैसे? फॉर्मूला है तो फॉर्मूला के वॉल्यूम अरे पर वॉल्यूम पता चलना चाहिए ना. कैसे? water in the tube. That's an indirect way of measuring. And this is all known as process understanding. I can measure certain quantity by either adopting a direct measurement or some kind of an indirect measurement. How to do that? You have to design your own process and then come up with the answer. Right? So I can always measure the volume by filling it with water. Of course, again that also I will have to do it multiple times. If you try to imagine what will happen when you try to measure, fill it with water and then empty that tube in a beaker, right, or a cylinder, measuring cylinder, some water will remain in the tube itself. So you may have to take out the complete water from the tube, okay, and that's going to be a challenge. So whenever you talk about any measurement, you have to really imagine what is going to be the problem in that and how will I take care of it. That's process. So when I say the process of solving an experimental problem, so when we teach these students, these Olympia students, how do you solve an experimental problem? So first you have to understand the object. It's there. You have to determine this and this using whatever method that you have. Then look for relevant equations which will give you that quantity. Once you look for that equation, then linearize that equation to decide which graph. So what do I mean by linearization? Any idea? I will give an example of this. Then spot the relevant variables for measurement. Choose the instruments to measure those variables. Collect the data with whatever procedure that you follow. Graph plotting. Have you plotted graphs? All of you? Have you done this? Uncertainty analysis or error analysis? Have you calculated error by any chance? Why should you calculate error? You were saying something not here. But you have to find out error in that value, right? Why do you have to find that error? आपने एक्सपेरिमेंट करने के बाद आपको जर्नल पे आप जिस पे लिखते हो रिपीट मार्क मिला है, ये वैल्यू बराबर नहीं है, आप फिर से करो एक्सपेरिमेंट, नहीं? Oh, you are lucky. Your teachers will remember their days, right? बहुत बार मिला होगा ना? Generally, maybe in schools we don't ask students to actually go back and check their data and do all this. But when you go for your higher studies, you will have this kind of situation many times. You have got certain answer, but your teachers say that no, this is not correct. Go back and do the rest. For example, simple pendulum. You got a value of say 10.2. What is the value that you expect? 9.8. Right? You got 10.2. If you can convince teacher that the error that I have calculated is maybe plus minus 0.5. So 10.2 plus minus 0.5. So your 9.8 lies in that. That's one of the way to convince that this is the way my experiment has gone and this is the error with whatever procedure that I have followed. I can justify my answer. But of course, more than that, there are many other factors why you should calculate error in an experiment, and then represent the final answer with significant digits. Like just because your calculator gives you 12 digits, you should not write all of them. There is some sense to that. So let's talk about this linearization process. What do I mean by that? So t equal to 2 pi root of L by G. Square both the sides. Then rearrange the terms and then compare it with straight line equation. When you do that, your y is nothing but t square, where x variable is L and your slope is 4 pi square upon G. That is linearization. Now why should I do that? because that tells me which graph I should draw. Generally, आपके लैब जब भी आप जाते हो तभी आपको कुछ तो पेपर मिलता होगा, जिसपे कौन सा ग्राफ प्लॉट करना है वो दिया है पहले से. We don't give a damn to what क्यों दिया है, वो क्यों नहीं दिया, ये क्यों दिया. This is the logic. This is the logic. So linearization tells you which graph to plot. Now this is an example which we are now going to solve. So this equation you all know, is equal to ut plus half ut. Right? I think all of you know. Good. So the experiment that we are going to do, not now, but a thought experiment. Then you have a steel ball here, and you have two photo games. How many of you know what photo gate is? Raise your hands. Oh, great. So many of you. Can someone tell me what a photo gate is? Those who have raised their hands. कोई भी एक. Photo gate. तो इतने सारे हाथ ऊपर आए थे.
Don't know, sir.
Okay, don't know. How many of you know what a photo gate is? कोई भी नहीं. Then I can tell you. Okay. Burglar alarm तो पता है. Burglar alarm. भी नहीं पता. Like चोर जाता है, वो अलार्म बजना चालू होता है. वो तो सुना होगा बचपन में कहीं पे. Maybe आप बचपन नहीं हो, but फिर भी तब बचपन. So you have a transmitter, you have a receiver, right? So if some object passes through that, okay, there will be a pulse created. That pulse go to a subsequent circuit, like your alarm circuit. That alarm goes on. Right? That's the burglar. That's your photo gate. So if I connect that photo gate right here, if object passes through that, so you have a transmitter, you have a receiver. If an object passes through that, there will be a pulse created. That pulse is given to a stopwatch. Stopwatch पता है आपको सबको? How many pulses do you need for a stopwatch to work? Start, stop. दो pulse. कोई भी stopwatch handle क्या होगा? Start, stop. So I need two pulses. So my first photo gate is going to give me the first pulse. Second photo gate will give me the second. Right? So my stopwatch starts at this photo gate and it stops at this photo gate. So I am getting the time for that steel ball to travel from this photo gate to this photo gate. Is that okay?
Yeah.
This distance is constant. Every time I am dropping the steel ball from the same height. From the photo gate 1. So I am not changing the position of photo gate 1 at all. What I am changing is the position of photo gate 2. Okay. So I have S versus T. This is the data that I have. Distance and time. Okay. And this is how I am doing the experiment. Now I am asking you, which graph will you plot so that I get G either from slope or from intercept? You have your notebooks with you, just figure it out and tell me. This is the equation. So now we are trying to understand the linearization process. How do you linearize a certain equation in terms of y equal to mx plus c? From that, how do you identify a y? How do you identify x? You don't need to differentiate any of this. Look at the equation and you are going to tell me the answer, but take some maybe 1 or 2 minutes to do that.
ट्वेल्थ में भी आता था
If the question is not clear, I can explain you again. फिर से करूं? एक स्टील बॉल है जो मैं ड्रॉप कर रहा हूँ. It's a free fall. Just छोड़ रहा हूँ. अभी मैं छोड़ रहा हूँ यहाँ पे, तो उसको मुझे टाइम मेजर करना है. यानी कि मैंने 2 फोटोगेट लगाए यहाँ पे, एक फोटोगेट यहाँ पे, एक फोटोगेट यहाँ पे. जब स्टील बॉल यहाँ से पास होगा, तभी एक पल्स क्रिएट होगी और मुझे मेरा स्टॉप वॉच स्टार्ट होगा. जब यहाँ से पास होगा, वो स्टॉप होगा. तो ये जो डिस्टेंस है 2 फोटोगेट के बीच का, वो है s, एंड देन आई विल मेजर टाइम फॉर दैट s. ये स्टॉप वॉच यहाँ से लेके यहाँ तक वो बॉल जितना टाइम लेता है वो उतना टाइम देगा. तो मेरे पास जो डेटा है s और t का है. तो अभी मैं क्या करूँगा, फोटोगेट मेरे 2 ये है, मैं ये डिस्टेंस चेंज कर रहा हूँ दूसरे फोटोगेट का. S1, S2, S3, S4, S5. I am getting T1, T2, T3, T4, T5. S और T का डेटा मेरे पास है. मैंने कंडीशन ये दी थी कि फर्स्ट फोटोगेट से स्टील बॉल का डिस्टेंस मैं सेम रखा हूँ. हर बार मैं यहाँ से ही छोड़ रहा हूँ. ये मैं चेंज नहीं कर रहा हूँ. ये यहाँ से मेरा सिर्फ सेकंड फोटोगेट चेंज. अभी मुझे करना ये है कि ये मेरा इक्वेशन है, तो मुझे g फाइंड आउट करना है, एक्सेलरेशन ड्यू टू ग्रेविटी. तो मैं ऐसा कौन सा ग्राफ प्लॉट करूं कि मुझे g जो वैल्यू है वो आइदर स्लोप से मिलेगी या फिर इंटरसेप्ट से मिलेगी. When I say intercept, y equal to mx plus c. C is called as intercept. M is the slope. Right? That's the straight line equation that you must have studied. How many of you have your answers ready? Raise your hand. Only one. I will wait.
अभी तो मैंने शेयरिंग में हमारे भी सीरीज तो बड़ी
He is constant. I am just doing it at one place. He is a constant value. You have to tell me what will have plot on y-axis and what will have plot on x-axis. Wait. Let them also. I will ask these answers. Also, you have to tell me if you need a break right now for 10 minutes.
No.
How many of you think you need a break for 10 minutes? Raise your hand. Okay. How many of you think you don't need a break for 10 minutes? After we are done with this problem, we will take a break for 10 minutes and then we will come. After this problem. I hope you are discussing the problem. not done. Not done. Are you doing it? Done. You have a doubt or you have an answer? Wait. Okay. Shall we get the answers in this group? Ready? Okay, let's start with that. Yeah, but so you will plot S on some axis and T on some axis, right? That is one answer she is giving. I'm not saying correct or wrong. That's just one answer, right? There is no marker here, right? M16. Yeah.
x-axis પર છે ને ડિસ્પ્લેસમેન્ટ થશે અને y-axis પર ટાઈમ
Any other answer?
सर फाइल पे हम डिस्प्लेसमेंट प्लॉट करेंगे और x में t स्क्वायर प्लॉट करेंगे
T square. और कुछ? Sorry? Same. Okay. Any other answer? कैसे है? कहाँ से? ये कहाँ से? Okay, the answer that he gave me, he has given me half answer, but I hope he will give me that complete. But V on y-axis and T on x-axis, but he is still not telling me what he means by V. How will I get? I mean, I know velocity, but how will I get that? How will you calculate that? That's what I want to know. Am I measuring velocity? So you tell me in terms of these variables. No? So what is that velocity? S by T. So just tell that. Simple. Okay, so what it means is S by T. So these are the possible options that you people have given. So what do you think? You think all of them are correct? Are all of them correct? नहीं गूगल पे नहीं मिलेगा नहीं मिलेगा गूगल पे हाँ उल्टा हो that's okay. Okay, so let me tell you, all these first three, there is a problem. Okay, there is a problem with these three answers, first three answers. Let me explain you why. When you talk about y equal to mx plus c, right? C जो है, it's a constant. Does it have any of the y or x term? No, it's a pure constant, right? When I plot, say s versus t, my my intercept is half GT square, right? So S versus T to gaya. Then you have this S versus T square or 2S versus T square, right? Even then, when you plot S versus T square, you have UT as your intercept. How many of you have assumed U to be 0? Right? Can U be 0? Where do I define this initial velocity? At photogate 1. Is it 0? No. But it's finite and constant. Because I told you that this distance from this steel ball to this first photogate is constant. Right? So U is going to be constant, but it's not 0. Right? So what I can do is something that he just said. Just divide the whole equation by T. Left hand side, right hand side. Just divide by T. This one. So S by T versus T. And I will get my value of G from slope. These are three possibilities. I divide the whole equation by T once and I plot S by T versus T. Then I divide it one more time if you want. Okay. I have S by T square versus 1 by T, but then I get it from the intercept. And if you still want to impress someone, right, the third answer. You get it from slope as well as intercept. So this is basically jugglery of variables. यहाँ से वहाँ से यहाँ लेके जाओ and then try to linearize it such that your intercept should not have any variable term. And whatever that you want, that quantity right now in that G, it should appear somewhere in the intercept or in the slope. That is linearization. Right? So looking at an equation and then changing these positions of variables is a skill. Unless you do it multiple times, so when you now enter your lab and whenever you get to see any new experiment, try to look at that equation and without looking at which graph to plot, you decide which graph to plot. And that will give you an idea that fine, this is the graph that I have to plot and yes, this is what they are given. Okay, fine. Then, fine. We'll take a break now. 10 minutes break. So it's 12 right now. So we'll come back at 12:10. Please do come back. लेंथ तो पता है आपको, लेंथ और टाइम के अलावा, ओके, सो आई विल ट्राई बॉब्स ऑफ डिफरेंट मास. व्हाट एल्स? ओके, सो जोर से मैं फेंकूंगा और देखूंगा कि कैसे होता है. ओके, आई विल चेक. Height, that's the angle, right? So angle at which I can take that bob and then leave it. Because normally आपके टीचर्स आपको बोलते हैं कि एंगल छोटा रखो. जिन्होंने साइंस सिंपल पेंडुलम का डेरिवेशन, सिंपल हार्मोनिक मोशन का डेरिवेशन किया है, उसमें एक अप्रोक्सीमेशन है sin theta nearly equal to theta. Right? That tells you that theta has to be very small because that approximation holds good for theta to be very small. Or air drag, different shapes of the bob. So there can be so many such variables. Now we know that all of these variables really don't make much difference in the value of t. When you measure time, okay, आप mass change करके देखो या कुछ भी, I mean it's independent of all of them, है ना? इसलिए आपको ये फाइनली आ गया फॉर्मूला t equal to 2 by root of L by G. सो कोई भी एक्सपेरिमेंट में बहुत सारे अगर वेरिएबल्स है, तो हमें सिर्फ दो वेरिएबल्स पे फोकस करना है, बाकी के सभी हमें कांस्टेंट रखने हैं. These are independent and dependent variables. So in simple pendulum, which is an independent and which is a dependent variable? Right? क्यों? L में इंडिपेंडेंट वेरिएबल और T को डिपेंडेंट क्यों बोलता हूँ? Yeah, why not the other way? Yeah, gravity is constant. So why don't I say that my L is dependent and T is independent? कोई कुछ बोल रहा है? उल्टा क्यों नहीं? इंडिपेंडेंट केस बोलिए ना.
सर क्योंकि L को हम डिसाइड करते हैं कि हमें उसे कितना मतलब हम
वेरी गुड, वेरी गुड. कि मैं L 10 में इंडिपेंडेंट रखता हूँ, टाइम देखता हूँ कितना है. L को 20 रखता हूँ, टाइम कितना है. 30, 40, 50, 60 में चेंज करने जाऊंगा. उल्टा मैं करूंगा, टाइम t इक्वल टू 1 सेकेंड के लिए L कितना करना है, ज़्यादा ही प्रॉब्लमेटिक होगा ना. तो अरेंज करना है L उतना कितना होता है, राइट? सो इट्स नॉट कन्वीनियंट. सो इट्स जस्ट द शेयर कन्वीनियंस दैट टेल्स मी दैट ओके, मैं L इंडिपेंडेंट दे रहा हूँ और T डिपेंडेंट दे रहा हूँ. जनरली एक्सपेरिमेंट करते वक्त टीचर्स टेबल्स में कभी कभी वैल्यूज दी रहती है. I have not actually looked at the papers that you get when you enter the lab, but I might ask this to teachers, like L की वैल्यू दी रहती है टेबल में, कितनी लेनी है? नहीं, they have to decide, right? So when you decide which value to take, suppose आपको मैंने 1 मीटर का लेंथ दिया हुआ है, थ्रेड या धागा 1 मीटर का दिया है, मेरी L की वैल्यू क्या क्या रहेगी? 5 वैल्यूज में बोला आपको 5 वैल्यूज देनी है. कोई लॉजिक है उसमें या मैं कोई भी ले सकता हूँ? कोई भी. फॉर एग्जाम्पल ये कोई भी को नंबर्स दे सकते हो आप. कैन यू टेल मी एनी 5 वैल्यूज दैट यू वुड लाइक टू टेक? 0.5 वॉट. अच्छा मीटर, ओके, दैट्स ऑल. 5 वैल्यूज बोला मैंने. 30 सेंटीमीटर्स, देन 30, 40, 50, 60 70 क्या होगा? अच्छा हाँ, मुझे लगा कहाँ गिर गया 70. सो यू आर ट्राइंग टू से 30 to 80 आप वेरी करोगे. धागा तो 1 मीटर का है. फेवरेट से क्या 30 to 80. एनी अदर वैल्यूज? सॉरी, कोई भी यानी मुझे से हम एक्सपेरिमेंट कर रहे हैं, कोई भी करके मैं लिख नहीं सकता हूँ ना. L equal to कोई भी. So I'm just asking you which values would you prefer? 30, 35, 45, 55, 10 centimeters space. Okay. Now, yes. जिसका रूट इजी हो वैसे. ओके फाइन. बाय द वे आप वहाँ पे जाके क्यों बैठे? आप यहाँ पे बैठे थे ना. मैंने ज्यादा तो क्वेश्चंस नहीं पूछे. He was giving answers and he was here. Anyways, that need not be our worry right now. Okay? My idea here is that when I talk about any independent variable, that independent variable should cover the complete range, okay, that is been given to us. What does that mean? I could have started with 20, 40, 60, 80. And why is that important? Let me give you another example of this. Thermistor किसी को पता है? Thermistor. Resistor किसी को पता है? Good. सबको resistor पता है? So thermistor is a kind of resistor whose resistance changes with temperature. Right? So thermistor is a resistor whose resistance changes with temperature. There are two types of thermistor, PTC and NTC. पॉजिटिव टेम्परेचर कोएफिशिएंट, नेगेटिव टेम्परेचर कोएफिशिएंट. इसका मतलब क्या है? पीटीसी में जैसे टेम्परेचर बढ़ता है रेजिस्टेंस बढ़ता है. एनटीसी में जैसे टेम्परेचर बढ़ता है रेजिस्टेंस कम होता है. राइट. सो यू टेक एनी ऑफ दोस थर्मिस्टर, दैट्स नॉट द इशू. द इशू इज व्हेन यू स्टार्ट चेंजिंग द टेम्परेचर. इफ यू चेंज इट ओनली इन से रूम टेम्परेचर से लेके मैं 80 डिग्री तक चेंज करता हूँ. प्रॉब्लम इज उस बीच में वो लीनियर बिहेवियर दिखाता है. But if I go above 80, maybe around 100, 120, 130, it deviates from the linearity. तो वो मुझे linear नहीं दिखाता, वो मुझे curved path दिखाता है. तो अगर मैंने ऐसे assume कर लिया कि थर्मिस्टर का ये रेंज में मेरा एक्सपेरिमेंट है, right? तो मुझे स्टैंडर्डाइज करना है उसको, कैलिब्रेशन इक्वेशन लेनी है, तो मैंने सिर्फ ये रेंज में उसको स्टडी किया, मुझे linear ग्राफ मिलेगा. पर अगर मैं वही थर्मिस्टर अगर ज्यादा टेम्परेचर के लिए यूज करता हूँ, I cannot use that equation. So I need to cover the whole range of independent variable, maybe up to 200 degrees centigrade, within which I am going to use that, so that I have information for each of these. अभी सिंपल पेंडुलम में आप इतना ले लो या फिर इतना ले लो पूरा. Simple pendulum is still linear because people have tested it. Okay? But it's always better that you cover the independent variable range completely. And why should you take systematically? Like मैंने एक 12 लिया, फिर बाद में 18 लिया, फिर बाद में 35 लिया, 48 लिया, नहीं ना? Systematically suitable steps में अगर लिया तो अच्छा रहता है ना? क्यों? Changes observe होते हैं, right? So if my L is changing in suitable steps, right? तो फिर dependent variable जो है T, वो भी सुटेबल स्टेप्स में चेंज हो रहा है या टी स्क्वायर सुटेबल स्टेप्स में चेंज हो रहा है, वो मुझे दिखाई सकता है. सो बाय जस्ट बाय लुकिंग एट द डेटा आई कैन सी वेदर माय ग्राफ इज गोइंग टू बी लीनियर और कर्व. दैट्स व्हाई योर इंडिपेंडेंट वेरिएबल शुड बी चेंज्ड इन सुटेबल स्टेप्स ओवर अ कंप्लीट रेंज. अनदर क्वेश्चन. एक मेजरिंग सिलेंडर है मेरे पास जिसमें से पानी यहाँ से बह रहा है बॉटम देयर. And I have been given a stopwatch, a digital stopwatch. So now, which is here? So these are two variables that you have. So you have data with this. So which is your independent and which is your dependent variable? Okay. There are only two options, right? Time independent, volume dependent. या फिर volume independent, टाइम डिपेंडेंट. एक मिनट ऐसे मुझे समझेगा. सो टाइम इंडिपेंडेंट, वॉल्यूम डिपेंडेंट, रेज योर हैंड्स. उसका मतलब ये है कि मैं सपोज आधे मिनट के बाद देखूंगा वॉल्यूम कितना है, 1 मिनट के बाद कितना वॉल्यूम है, 1.5 मिनट के बाद कितना वॉल्यूम है, राइट. सो टाइम मेरा इंडिपेंडेंट है, वॉल्यूम मेरा डिपेंडेंट है. कि इतना इंटरवल ऑफ टाइम वॉल्यूम कितना है, इतना इंटरवल ऑफ टाइम वॉल्यूम कितना है. जब मैं बोलता हूँ वॉल्यूम मेरा इंडिपेंडेंट है और टाइम डिपेंडेंट है, तभी मैं ये बोलता हूँ कि इतने वॉल्यूम के बाद कितना टाइम हुआ, इतने वॉल्यूम के बाद कितना टाइम हुआ, इतने वॉल्यूम के बाद कितना टाइम, राइट? दैट्स द क्वेश्चन. सो माय फर्स्ट ऑप्शन, टाइम इंडिपेंडेंट, वॉल्यूम डिपेंडेंट. रेज योर हैंड्स. यहाँ वहाँ देखने की जरूरत नहीं है, आपको क्या लगता है? ओके, उल्टा, वॉल्यूम इंडिपेंडेंट, टाइम डिपेंडेंट. Okay. Rest of you not decided? Can prove? नहीं, आप सभी वहाँ पे. Any opinion? Let me repeat the question. Time independent, volume dependent. Raise your hands. Time independent, volume dependent. Raise your hands. Down. Volume independent, time dependent. Now I can see some hands. Okay, good. Why do you say volume independent and time dependent? Because majority of you have raised your hands within that. Any justification for that? जस्टिफिकेशन या फिर जो जिसने बोला है टाइम इंडिपेंडेंट और वॉल्यूम डिपेंडेंट, उसका कोई जस्टिफिकेशन?
सर उधर स्पेसिफिक टाइम में इतना वॉल्यूम डिक्रीज हुआ तो उसके ऊपर हम ग्राफ पे ड्रॉ कर सकते हैं कि वॉल्यूम का चार्ज लो आ रहा है तो इतने इंटरवल ऑफ टाइम में लो आ रहा है इसमें, तो आप हम टाइम के हिसाब से वॉल्यूम को एडजस्ट कर लेते हैं. जैसे कि अगर 10 सेकंड्स पे अगर 100 ml आउट हुआ उस हिसाब से हम लोग वो ग्राफ ड्रॉ कर रहे हैं.
उल्टा, यहाँ पे बहुत जन ने हाथ खड़े किए थे, वहाँ पे भी किए थे. वॉल्यूम इंडिपेंडेंट एंड टाइम डिपेंडेंट. व्हाट इज द जस्टिफिकेशन? कम ऑन आंसर. आई मीन उसमें क्या है? राइट है, रॉन्ग है. यस. हाँ, सो दोनों केस में यहाँ पे अभी आपने दिया ना जवाब, दोनों केस में मैं वॉल्यूम और टाइम का ग्राफ प्लॉट करूँगा. बट मेरा सवाल ये था कि मैं वॉल्यूम को एक्स एक्सिस पे लूँ इंडिपेंडेंट करके या वाई एक्सिस पे लूँ डिपेंडेंट करके. तो आपका आंसर क्या था? राइट. बट आप ये बोले होते कि 500 ml के लिए मैं कितना टाइम लगेगा वो मैं देखूंगी. राइट. एग्जैक्टली. तो फिर क्यों वैसा क्यों कर रहे हो आप? अब अगर मैं जिन्होंने बोला था कि टाइम इंडिपेंडेंट और वॉल्यूम डिपेंडेंट, उसमें तो वो हो सकता है 30 सेकेंड्स, 60 सेकेंड्स, 90 सेकेंड्स, वॉल्यूम तो चेंज हो गई. ऑपरेशनल प्रॉब्लम्स क्या है इसमें?
डिपेंड करता है हमारे लिए कौन सी इंफॉर्मेशन ज्यादा यूजफुल है.
यूजफुल या फिर आई एम अगेन रिपीटिंग माय क्वेश्चन, डू यू सी एनी प्रॉब्लम इन एनी ऑफ दिस मेथड्स? नो? श्योर? नाउ लेट मी आस्क यू, मैंने टाइम इंडिपेंडेंट लिया है, वॉल्यूम डिपेंडेंट लिया है, उसमें 30 सेकेंड के बाद क्या वॉल्यूम, 60 सेकेंड्स के बाद क्या वॉल्यूम, 90 सेकेंड्स के बाद क्या वॉल्यूम. राइट. ये मैं नोट करूंगा. अभी ये नोट करते वक्त वो जो मार्क्स है उसके ऊपर, ग्रेजुएशन मार्क्स है सिलेंडर के ऊपर, अगर मेरी वाटर लेवल 2 मार्किंग के बीच में आती है, कौन सा रीडिंग लूंगा? प्रॉब्लम समझ में आ रहा है? अगर 2 मार्किंग के बीच में मेरा रीडिंग आ रहा है, मैं रीडिंग लूँ कौन सा, ऊपर वाली ले लूँ या नीचे वाली ले लूँ? आई एम इन ट्रबल. राइट. इन दैट केस इफ आई टेक इट अदर वे अराउंड, कि मैं वॉल्यूम को इंडिपेंडेंट ले लूँ कि 1000 से 900, 900 से 800, 800 से 700 हर एक इसमें टाइम कितना हो रहा है। स्टॉपवॉच सबने यूज किया है। स्टॉपवॉच में दो बटन्स रहते हैं, एक यहाँ पे स्टार्ट स्टॉप वाला, एक यहाँ पे लैप टाइमिंग वाला। नहीं नहीं है तो देख लीजिए। वो लैप टाइमिंग जो है वो आपने एक बार प्रेस किया तो उस मोमेंट को क्या टाइम है आपको मिलता है, पर स्टॉपवॉच बैकग्राउंड में चालू रहता है। तो फिर 1000 से 900 तक मैंने वो अगर बटन प्रेस किया 900 पे, मुझे समझेगा कि 900 ml जाने के लिए कितना टाइम लगा। फिर 900 से 800 में जब आता है तभी मुझे कितना टाइम मिला। नाउ आई एम सेफ, आई हैव वेरी वेल डिफाइंड कि 800 ml यानी कि ये लेवल है, 700 को ये लेवल है। अगर मैं उल्टा करता हूँ तो एक करस्पॉन्डिंग टाइम के लिए अगर मेरी वॉल्यूम जो मार्किंग है वो अगर बीच में वाटर लेवल आती है, then I'll end up in trouble. So it all depends on how am I performing that experiment. Okay? How am I performing that experiment? Charging of capacitor पढ़ा है आपने? कैपेसिटर पता है आपको? चार्जिंग का ग्राफ पता है आपको? चार्ज होता है कैपेसिटर। समझो मैंने आपको ऐसा एक एक्सपेरिमेंट दिया, चार्जिंग ऑफ कैपेसिटर। मैं देख रहा हूँ वोल्टेज और टाइम कि एट सर्टेन टाइम कितना वोल्टेज है, फिर टाइम पे कितना वोल्टेज है। इज द सिचुएशन क्लियर? चार्जिंग द कैपेसिटर, राइट? ये टाइम पे इतना वोल्टेज है, ये टाइम पे इतना वोल्टेज है। उसमें मैं टाइम इंडिपेंडेंट लूँ या डिपेंडेंट लूँ? टाइम इंडिपेंडेंट, वोल्टेज डिपेंडेंट। एनी आंसर? Any other answer? Is the question not clear? Anybody? इनको क्वेश्चन समझा नहीं है, प्लीज रेज योर हैंड। I can again explain it to you. Okay. चार्जिंग ऑफ कैपेसिटर है, मैं कैपेसिटर को चार्ज कर रहा हूँ और मैंने कैपेसिटर के अक्रॉस एक वोल्टमीटर लगा दिया है और मैंने आपको स्टॉपवॉच दिया है। तो आपको जस्ट फाइंड आउट करना है कि दो आपको डेटा कलेक्ट करना है, टाइम और वोल्टेज की। तो स्टार्ट द स्टॉपवॉच और क्या वोल्टेज है वो देखते जाओगे। तो उन केस में टाइम मेरा इंडिपेंडेंट रहेगा या वोल्टेज मेरा इंडिपेंडेंट रहेगा? आप जवाब देने से पहले आप मुझे एक क्वेश्चन पूछ सकते थे, वोल्टमीटर कौन सा दिया है? एनालॉग वाला दिया है, इसमें वो मार्किंग्स है, तो यही प्रॉब्लम है ना। या डिजिटल दिया है तो कोई फर्क ही नहीं पड़ता, ये भी नंबर्स है वो भी नंबर्स है, कोई भी कुछ भी ले लो। समझ रहे हो? सो इट ऑल डिपेंड्स ऑन व्हिच इंस्ट्रूमेंट दैट यू आर यूजिंग, दैट इज हाउ यू डिफाइन योर इंडिपेंडेंट एंड डिपेंडेंट वेरिएबल। ओम्स लॉ किया है, ओम्स लॉ कितने जने नहीं किया है? ओम्स लॉ नहीं किया है, आपने नहीं किया, नाइस स्टैंडर्ड, नहीं किया, विल नॉट डिस्कस दैट। ओके, इंस्ट्रूमेंट चूज जब भी करते हैं, राइट? सो हम इंस्ट्रूमेंट जब भी चॉइस होता है इंस्ट्रूमेंट का, देयर आर टू फैक्टर्स ऑन विच वी कैन चूज द इंस्ट्रूमेंट। व्हाट आर दिस? ईज ऑफ मेजरमेंट, लीस्ट काउंट ऑफ द इंस्ट्रूमेंट। What do you mean by ease of measurement? सिंपल पेंडुलम में, राइट, आपको बॉब दिया जाता है, बॉब का आपको रेडियस फाइंड आउट करना है। आप रेडियस फाइंड आउट करते हो, किससे करते हो? वर्नियर से। समझो मैंने वर्नियर नहीं दिया, मैंने एक स्केल ली और बॉब उसके ऊपर रखा, यहां से देखा, यहां से देखा, डायमीटर मिल गया, है ना? एक स्केल रखी मैंने यहाँ पे, बॉब रखा यहाँ पे, और फिर ये जो एज है बॉब की वो कहाँ कोइंसाइड हो रही है, ये एज कहाँ पे कोइंसाइड हो रही है, डायमीटर तो मिल गया। व्हाई डू आई नीड वर्नियर कैलिपर? Okay, one answer that I have got is like you get an accurate answer. You will not get. Like using vernier will give you accurate answer, right? That's what you want to say. All of you agree with that?
Yes, sir.
Let's do some calculations. You all can see this or no? You can't see this? Okay. Suppose you have some L dash equal to say 40.6 centimeter. Length of the thread. दिख रहा है? नहीं.
सर बॉन्ड बढ़ेगा.
So suppose length of the thread say L dash is 40.6 centimeter. Radius of the bob is say 0.56 centimeter. Because you have used the vernier caliper of least count 0.01 centimeter, right? So I'm just giving you some figure. So my L equal to L dash plus R. What should be my answer? But if you still want me to reduce your calculation burden, okay. Okay, so this is correct. You just told me that's the value.
But sir, 0.1 की error है vernier scale में, तो आपको
0.01 centimeter. He's saying 40.7. नहीं, राउंड ऑफ किया तो 40.7 होता है, इतना नहीं. 40.6 नहीं रहेगा. How many of you say 40.7 लिखना चाहिए और कितने? I mean, okay fine. 40.7. Raise your hands. Okay. तो वहाँ पे लिख के क्यों हाथ ऊपर कर? हाँ सही होती है. Yeah, right. I have a daughter. She's always right. Okay. How many of you say 40.66? Okay. Now, the moment you say it's 40, it should be 40.66. Do you know what you are trying to say? You are trying to say that you are very sure about this big length scale up to the second decimal place. That means you have measured this complete length with an instrument, some instrument with this count of 0.01 centimeter. Is that correct? No. You have measured only a small part of that big length with 0.01 centimeter. Right? And the large part of that is measured with just 0.1 centimeter. So can you claim accuracy of 0.01 centimeter over this large length? No. Right? That's why it should be 40.7. Right? So now let's come back to our earlier question. Okay. तो फिर अगर पॉइंट मुझे रखना है, वर्नियर यूज क्यों कर रहे हैं? छोड़ दो, टेक अ स्केल, मेजर इट, और आई विल गिव यू अ थ्रेड, लपेटो उसको 2.5 पाई आर मिलेगा,
तो उसके लिए वर्नियर स्केल में डायरेक्टली आपको
डायरेक्टली मिलेगा. So it's basically convenience, ease of measurement, right? So try to understand why you are using that instrument. You are not really claiming a least count of 0.01 centimeter by just using that vernier scale. But what you are trying to do is just ease of measurement. कि मैं बॉब को स्केल पे रखूंगा और यहाँ से देखो, यहाँ से देखो, it will be so cumbersome. Right? You may not be, looking at perfect perpendicular position. There might be so much of problem. Instead, ले लो vernier, measure करो, restrict yourself to that 0.1 centimeter. As simple. Right? So that is the ease of measurement. Right? Second is least count. Now, how does that play a role? Generally, रूल ऐसा है, कोई भी मैं मेजरमेंट करता हूँ एक्सपेरिमेंट में, I can tolerate an error of 1%. 1%, right? 1 by 100, 1% is 1 by 100. Everybody agree? So उसका मतलब क्या है? Let's try to see. So हमारे पास अभी समझो मैंने आपको एक थ्रेड दिया है और थ्रेड का मैंने लेंथ मेजर करना है. I am using a scale of 0.1 centimeter. So अगर मैं 1% बोलता हूँ तो डेल्टा एल बाय एल, that is called as relative error. Relative error. Delta L is the least count of the instrument. L is the length actually measured. Right? So अगर मैं उसको 1% बोलता हूँ तो उसका मतलब क्या होता है? मेरा जो मैंने मेजरमेंट किया है वो 100 टाइम्स least count से बड़ा होना चाहिए. 1 by 100 ना. So अगर मेरा मेजर्ड क्वांटिटी 100 है, मेरा least count 1 होना चाहिए. समझ रहे हो? डेल्टा एल शुड बी 1 एंड एल शुड बी 100 टाइम्स द लीस्ट काउंट. ओके, तो अगर मेरा 0.1 सेंटीमीटर यहाँ पे लीस्ट काउंट है तो मेरा लेंथ मेजरमेंट कितना होना चाहिए? 1 by 100 इक्वल टू 0.1 अपॉन 10, राइट? सो इट शुड बी 10 सेंटीमीटर. इसलिए आप आपका सिंपल पेंडुलम का एक्सपेरिमेंट चालू करते हो मेजरमेंट एटलीस्ट 10 सेंटीमीटर से तो चालू करते हो. मे बी आपको कॉलेज में 20 से आप चालू, स्कूल में 20 से चालू करते हो, बिकॉज फॉर 10 सेंटीमीटर द पेंडुलम ऑसिलेट्स सो फास्ट दैट यू वोंट बी एबल टू एक्चुअली मेजर दैट टाइम. बहुत फास्ट होता है. सो दैट इज द मीनिंग ऑफ 1%. नेक्स्ट क्वेश्चन, टाइम मेजरमेंट. हाउ मेनी ऑसिलेशन शुड वी काउंट? 20. Any other answer? Why 20? 2020 cricket is there. Why 20? Why not 30? Why not 40? 50 ले लो, 100 ले लो. Who stops? Of course, teachers might stop. Why 20? Any answer? Why not 50 at least? जितने ज़्यादा उतना अच्छा ना. Any answer? What do you mean ease of the experiment? You really think that? The moment you increase, so then why not take maybe 5 oscillations and finish it off? Very less. Who decides this, whether it's very less or very large? Who decides that? Because this becomes a qualitative statement. ना? 20 और 50 nearly equal है, 10 का लिया या 5 का लिया तो very less है. Who decides all these things? Any justification? Let's start with this. फिर से वो 1% वाला फंडा लाते हैं. मेरा घर में 1% रखना है मेजरमेंट, टाइम मेजरमेंट. तो अगर वो मुझे 1% रखना है, इसका मतलब क्या है? The choice of either the measured quantity or the measuring instrument must be such that the reading is at least 100 times the least count. ये अपना फंडा है. तो least count of the stopwatch कितना था? 0.01 सेकेंड था. सबको पता है? least count of the stopwatch 0.01 सेकेंड है. हाँ? Agree? With that 1% के लिए delta d by t equal to 1 by 100 equal to 0.01 upon 1, right? So 1% के लिए 1 second is enough, right? Even if I measure 1 second, like 1% length measurement वहाँ पे जब मैं बोल रहा था तो 0.1 सेंटीमीटर लेंथ डिस्काउंट के साथ 10 सेंटीमीटर was enough, right? Similarly यहाँ पे 1 second is enough, तो एक ऑसिलेशन भी बहुत हो गया. लॉजिक तो बराबर लग रहा है ना? कुछ तो गड़बड़ नहीं है. एक ऑसिलेशन ले लो, खत्म एक्सपेरिमेंट. प्रॉब्लम क्या है? T1, T2, T3 सेम आते आपके. हाँ, अगर आपने डिसाइड किया तो कुछ भी हो सकता है ना? T1, T2, T3 हमारे कभी सेम नहीं आते. It changes. And since it change, why does it change? Why does the T1, T2, T3 change? पहली बार हमें 3 बार क्यों लेने के लिए बोलते हैं? Okay, what she is trying to say is exactly उसी जहाँ से पहले किया था उसी यहाँ से हम छोड़े हैं कि नहीं पता नहीं. But that fine, I can always do that ना. मैं कहीं कुछ तो एक स्टॉपर वगैरह लगा देता हूँ यहाँ पे और बॉब यहाँ पे लाके उसको चिपका देता हूँ and then leave it. वापस आके टकराएगा उसको? टकराएगा? See, this dampening will not actually make that bob come and again touch that plane. Now, I can actually do that. I mean, I can always release it. But there is something known as response time, reaction time. Hamara reaction time. And that I think you know very well. What is it? What is this? What is this? That advance, sir? If I just told you, what happened? Just blink his eyes. Right? The moment I made this action and the moment he blinked his eyes, there was a delay. Right? That's his reaction. चौक तो बहुत बार आया होगा ना आपके पास? नहीं आया? चौक एक बार या 2 बार तो आना ही चाहिए, तो कुछ जिंदगी में बनोगे. Jokes apart, but that's your reaction. Now this reaction time is not allowing you to keep, your second decimal place same every time. क्यों? क्योंकि जब भी आप बॉब छोड़ते हो, right? You need not start taking the data the moment you leave it, ना? Let it oscillate, right? और कुछ तो मार्कर रखो. जब भी उससे क्रॉस होगा, you start your stopwatch. फिर से आके फिर से आएगा यहाँ पे तो stop your stopwatch, right? That's how you do your measurement. So you are not sure that you have started the stopwatch exactly at that point when you wanted to start. Okay? It might happen कि वो थोड़ा सा आगे गया और आपने नोटिस किया उसको, अरे ये गया और आपने स्टार्ट किया. स्टॉप करते वक्त यू आर नॉट रियली श्योर कि आपने उसी मोमेंट उसी जगह पे उसको स्टॉप किया. ये जो वेरिएशन है कि आपने जो देखा, सेंस किया यहाँ पे, फिर वो हाथ को कंट्रोल गया और आपने स्टॉपवॉच दबाया वहाँ पे, स्टॉप किया. वो जो रिएक्शन टाइम है, that does not allow you to have hold on that second decimal. इसलिए कभी आपको 12.14 मिलता है, कभी आपको 12.11 मिलता है, कभी आपको 12.16. you get that variation. Okay. But we are not that bad कि 0.1 वाला भी change हो जाए, नहीं. First decimal place तक तो हम ठीक ठाक ही है, ना हमारा reaction time बुरा नहीं है. So if that is the case, then let's not stick to 0.01, no? And then we stick to 0.1 second. And now with 0.1 second, how much time you should measure? 10 seconds. Okay, so if you know कि 1% error के लिए मेरा 10 second measurements proper है, then you go back to your apparatus and check how many oscillations you need to count 10 seconds. हो सकता है 12 oscillations में 10 seconds complete हो रहा है, 15 ले लो, maybe 17 में हो रहा है 20 ले लो, 6 में हो रहा है 10 ले लो, and that's how that number comes. So 20 is not a God-given number, right? कि हमेशा 20 oscillation ही लेनी चाहिए. If your system is really moving very slow, you can still go ahead with 10 oscillations and you are done with it. That's the logic. So that is how one actually understands how many oscillations one should take. And when we tell this to our students, Olympiad students, the main idea is you can save your time. What do you mean you can save your time? Suppose if there is some system which is moving very slowly for certain configuration, you need not keep taking 15 oscillations, 20 oscillations. Just take 5 oscillations, जिसमें 10 seconds complete हो रहा है, and then when you change that configuration and it starts moving fast, right? You increase the number of oscillations, you save your time. But more importantly, this question of why am I taking this number and why not other is very important, and one should understand that. What's the time? It's 1 o'clock. What is the time limit? 1 o'clock? Oh, okay. Maybe I will take one more concept or okay. Students' favorite question to teachers. कितने ratings देते? ये तो I think सब पूछते हैं, right? Let's try to discuss this today and then we will stop. I will not be able to complete my slideshow, but that's okay. अगर आप किसी को कन्विंस करना है कि मेरा ग्राफ स्ट्रेट लाइन है, कितने पॉइंट्स चाहिए? 3, और समझो 3 में से 1 पॉइंट जो है वो ऐसे परफेक्टली लाइन में नहीं रह रहे, वो थोड़ा सा बाजू में, मैं उससे कर्व भी प्लॉट कर सकता हूँ, है ना? आपको एक्चुअली पता नहीं है वेरिएबल कैसे बिहेव कर रहा है, आपको एक्चुअली पता नहीं वेरिएबल कैसे बिहेव कर रहा है. सो व्हाट विल आई डू? सो यू नीड एटलीस्ट 5 पॉइंट्स. एक पॉइंट चलो लाइन पे है, बाकी 2 पॉइंट्स इक्वल डिस्ट्रीब्यूटेड है. So in order to convince someone that it is a straight line, you need at least 5 data points on the graph paper. And if that is the thing, you need 5 data sets in the table. So teachers पे तो मेहरबानी करो, 6 ले लो. Right? So that's how that number comes. You should not actually ask this if it's a straight line graph. 5 to 6 data sets are more than sufficient. You should not take more than that unless it's written कि आप 8 data set ले लो. तभी आप अपना दिमाग लगा के 5 ही मत ले लो. Right? कोई तो एग्जामिनर मार्क्स काट देगा. But you should understand if you have a straight line graph, then 6 to 8 data points are more than sufficient. Right? You need not. But if it's not linear graph, okay, if it's something like this, some graph, right? Don't worry about that. It's just then the situation is a bit different. What is it? That I think you have not done this, right? Do you have any other graph? Okay, I think I have. This graph. This I think you must have done. Angle of incidence and angle of deviation using prism. है ना? वहाँ पे what you should do here is that fine, you have this angle of incidence in 30, 40, 45, 50, 55 and 60, right? You know that answer is going to be somewhere here between 40 and 50, right? What I could have done is that I could have taken this data at equal intervals, and once I